Good day, guys. Can you all hear me? Okay, let's give those who are still trying to join about 2 minutes so that at least they can get a chance to join, and then at 20 past, let's say 23 past 1, we will start. Let's give them some few minutes. In the meantime, is there anyone who would like to share with us what is a fraction or what is a percentage? Those are the two things that I want us to discuss today and tomorrow, probably, and also next week. Anyone who would like to share what is a fraction, or what is a fraction look like, or what is it used for, or maybe share something on percentage. Anyone who have a view on that? Anyone who would like to share? Would like to share with us what is a percentage? Or a fraction? Just to give a quick summary on fractions, if you remember, we did talk about the addition of fractions, and also we talked about multiplication of functions, we talked about subtraction of functions, and we talked about division of fractions, and all those binary operations we actually checked when it comes to fractions. And also we talked about the conversion of fractions to decimals, and also from decimals to fractions. And also we talked about how you convert a proper fraction or an improper fraction, and you convert it to a mixed number. We did all those things, but the question still remains: what is a fraction and what is actually a fraction is used for? So a fraction is a way of representing parts of a whole. Let me first write that, and maybe it's going to be easy for us to move forward. So we say a fraction is a way of representing, let me start here, representing parts of a whole. And then we also said that a fraction has two parts. Let me also write this one. A fraction has two parts. It has two parts. When I mean by two parts, I mean a fraction can be written in the form a over b. And then when it comes to this part, so we say that the top part, or a, we called it a numerator. And then the denominator, which is b, the number which is actually at the bottom, we called it a denominator. And then when we are talking about the numerator, what we are actually talking about here is this: how many parts do you have? Because these fractions actually are not just numbers that have no meaning. These fractions are actually used to describe parts of a whole. In other words, how much have been used or how much is still available to be used in part of a whole thing. So this numerator here is the one that is actually telling us or the one that is showing us how many parts do you have, and also the denominator is the one that shows how many equal parts the whole is divided into. Let me give you an example of what I mean by this, because this one, how much you have, this one is how many equal parts or how many total equal parts the whole is divided into. So let us take an example here. Maybe it's gonna make a lot of sense. Suppose that you are having a 3 over a 4. Let me just say you have a 3 in the numerator and you have a 4 in the denominator. How do we read this? So in order for us to read this, we can say that there are several ways to read this. One way, you might say that we are having 3/4. This is going to be 3/4. That's the first way to read this. The second way you can read this fraction over here is to say that we are actually having 3 over 4. That's also another way of reading this, 3 over 4. That's also another way to actually read this thing here. The last one that I actually like more than all of these is this reading of this whole thing, which actually says I have this is not the right 3. I have 3 things. So I have 3 out of 4. So these are 3 ways of reading the same thing. So what does this thing actually represent? Remember that this is just the reading, which is telling us that it's 3/4 or 3 over 4 or 3 out of 4. So what does this thing simply mean? Let me give you a simple example here. So the meaning of this, it means that there are three out of 4 equal parts. So equal parts. That is the meaning of this fraction here. And an example would be like this. If let's say I have this, I'm gonna call this circle here, suppose it is a pizza. So we have this pizza here, and then you decide to cut this into 4 equal parts. Now that you are having this pizza here, and then you eat this slice, and then you eat this slice, and you eat that slice, which means that this fraction here is actually telling you that you have eaten 3 slices or 3 pieces out of the 4 available pieces of this pizza. Another example is 1 over I have a 1 in the numerator and I have a 2 in the denominator. So how do you read this? We said that this one is the same as 1/2. So this is actually how you read this thing over here. Or you can think of this as just 1 over, this is 1 over 2. So you can also read it as that. And the last one is the one that I actually like, which is actually telling you that out of 2 things that are there, I have 1 out of 2. Out of 2. This is how you actually read this particular function. This particular fraction over there. And then if you are looking at the meaning of this fraction here, it is actually saying that you have 1 out of 2 equal parts. That is the meaning. So you have 1 out of 2 equal parts. Another way you can think of this, if let's say you are having an apple, let me draw a nice apple here, and then this apple of yours, you cut it so that you are having 2 pieces or 2 halves of this apple, and then you decide that you're gonna eat only the side and leave one in the fridge. So this one here is telling you that I have eaten 1 out of 2 equal pieces. That is one way of actually looking into this one fraction there. Another fraction will be you are having a 5 and then you have an 8 in the denominator. And how do you read this? This is also simple because you are having 5/8. So you have 5/8. So if you look into this one here, this THS here is actually telling you that I am having an 8 in the denominator there. That is one way to actually look into this. And also another way you can look into this, you are having a 5/8. That is another way you can actually read this fraction there. And the last one, which I actually like more than all these interpretations, is that out of 8 equal parts, I have taken 5. So I have 5. So this one is 5 out of 8. So this is how you read this particular function fraction here. And then the next thing here is actually going to, so it's 5/8, and then you have 5 over, and then you have 5 out of 8. And this one is telling you that, to give you a simple analysis, or actually what will this thing actually mean in real life. Let's say you are having a chocolate bar. So you have a chocolate bar, right? And then out of this chocolate bar, you decide that you're gonna divide this into 8 equal pieces. So how many pieces do I have now? 1, 2, 3, 4, 5, 6. Let me Let me add one this side. So I have 1, 2, 3, 4, 5, 6, 7. Let me add another one. So this one is your chocolate bar that is having 8 equal pieces. You are having this, or maybe you are having 8. You have 7. You have 7 friends, and you are the 8th friend. You are the 8th amongst your friends. So the total of you is 8. And then you decide that, okay, let me divide this bar into 8. Of course, I'm gonna give 6 of my loyal friends pieces, and then the 8th one I'm not gonna give anything. I'm gonna keep it. So you decide that, okay, I have these things here, and then after that you decide that this one will be eaten, this one will be eaten, this one will be eaten, and this one will be eaten, and this one will be eaten. So I have 1, 2, 3, 4, 5. So 5 of your friends decide to eat their pieces, and then you are left with this. So this thing would actually mean that out of 8 equal pieces, 5 pieces have been eaten, or 5 pieces have been given away. This is one way to actually look into this fraction over there. Another fraction will be, I have 2 over 3. This is actually, if you want to read it, you can say it's 2/3, or you can say that it is 2 over 3, or you can say that you have 2 out of 3. So this is actually other ways of actually representing or actually reading this particular fraction, which means if, let's say, I'm just gonna make an example here, you had maybe a loaf of bread, and then you cut it into 3 equal parts, and then you eat this one as a breakfast, you eat this one for lunch because it is lunch now, and then when it comes to this one, you are waiting to keep it for supper. So you can say that I have eaten 2 out of all these 3 pieces. That is the meaning of this nice fraction that is there. And the last one will be 7. Let's say I have 7 over 10, and then this one you can say it is 7/10, or you can say it is 7 over 10, or you can think of this as just saying 7 out of 10. Those are the 3 ways to actually read this fraction. And also, more importantly, you can think of this as, suppose that we are having 10 students and they are writing a test, and then out of these 10 students, only 7 actually passes the test. So we have 7 students passed the test out of 10 students, or out of 10 marks you got 7 out of 10 marks. So that is actually one of the ways of actually reading these fractions over there. But now, today, I want us to talk about percentages. What are percentages and how they are actually used? This is one of the important topics that you will ever have to deal with, because first of all, when you're buying things, you'll find out that there are discounts. When you're buying shares, for instance, you'll find out that the shares can either grow by a certain fraction or percentage. And then more importantly, you find out there's this thing called the tax. It can be capital gain tax, it can be pay as you earn tax, it can be land tax, it can be all these kind of taxes, which we will actually deal with at a later stage in this course. You will find out actually that percentages are actually used in so many parts of our daily lives. And also, one more important thing is that if, let's say, you are actually working in an insurance company, and or you are working in another company whereby you are earning according to a commission, you will find out that percentages are actually much more used in those contexts. So it is very much important to actually understand what is a percent, what does it mean, how do you convert percentages to fractions, and how do you convert fractions to percentages, and also how do you convert percentages to decimals. Those are some of the important things that you will ever have to deal with. Before I can define this percentage thing, anyone who have a question around these fractions, before we can, this little bit of summary of fractions, around fractions, you can actually unmute yourself and ask the question so that we can start to move forward. Any question? Okay, that is actually good, because we're still planning, since in each of these semesters we're supposed to have, let's say, about 4 tests in semester 1, and also in semester 2 we have 4 tests, so that we have a total of 8, so that we can pick the tests that we think are the best out of the 8. So for me, I always like us to have time so that we can write a test, so that we can have many tests as possible. Usually the tests that you write in the first semester, they are way too easy, and then the test that you write in the second semester, because there is so many things to cover in a short period of time, so you usually don't get enough time to prepare all those things. My advice would be, if it is possible, let's try and have as many tests as possible in the first semester, and then in the second semester we try and write the remaining test, and then it will be good for us, so that we can have a nice average of these tests at the end. Any questions so far? Saleni? Sanele Maketleni. Do you have a question? Sanele does not have a question. We don't have questions. Oh, it's fine. Okay. So let's start and talk about this percentage thing and get it out of the way. In simple terms, a percent is a way of expressing a number as part of 100. That's simple at its best. It's just a percent. It is a way of expressing a number as a part of 100. So that is a percentage. Let me write this as a definition, so that maybe when you're revising, you will be able to actually understand what is a percent. Let me write this here. Said a percent is a way of expressing let me start here, a number as a part of 100. That is a percent. In other words, what do we mean by a percent? This percent thing, this is not a good looking line. Let me try and make sure that this is actually written in a proper way. Okay. So what does a percent mean? We just say a percent. A percent means this. It means per 100. I think that's the right way to write it. Per 100. So this is a percent. Let's look at what this the percent actually means. So maybe that if we can actually look into that, we'll be able to give it into context. Let me look for an example here. This is an example, or let me say it is a meaning behind a percentage. Right. Suppose that if you have a loaf of bread, you have a loaf of bread. You have a loaf of bread, and you cut it. You cut it into, this is not right, into 100. So you cut it into 100 equal slices or equal pieces. Let me write slices instead. Equal slices. Then what is a percent? So you have one bread. This one bread now, you decide to cut it into 100 equal pieces. Then 1% is the same as 1 over 100, or it is one slice out of 100 slices. Let me write this here. It is one slice out of 100 available slices. That is what is a percent. Again, I said a percent is a way of expressing a number as a part of 100, which means that a percent means per 100. If you are having per 100, it means if you were having a loaf and you divide it into 100 equal slices, then 1% or a single percent, it is the same as one slice out of 100 slices that are available. Now, if let's say you use that context and you understood that, let me just say examples, that 1% is equivalent to 1 over 100 available things, then what is actually going to be a 2%? And B, what is actually going to be a 10%? And you have, let's say 10%. And then here, I'm going to have my C here and say what is going to be a 25%. And then I have my D. And my D is what is actually going to be a 50%. And then I also have my E at the end. And we are having a 75%. And then lastly, we have an F. What is going to be 100%. How does these questions are actually asked in the exam? We usually just say convert the following percentages to fractions. So this is the first thing that we usually do. And now we know that 1% is the same as 1 over 100. So we want to convert this nice thing there, then which means that 2% is just the same as 2 times 1%. We know it is 1 over 100, so it is 1 over 100, and this whole thing is just going to be the same as 2. We know that 2 is the same as 2 over 1. 2 times 1 is going to be 2 over 100, and also at the same time, this thing here, you know that there is only 1 2 out of 2, and also we have 52s out of 100, which means that 2% is actually telling us that we have 2 out of 100 equal pieces. That is actually what is 2%. 2% a piece is just 2 equal things out of 100 available equal things. So this is actually our 2%, or 1 over 50. And if you wanted to actually convert this to a decimal, you can actually do that, because the first thing that you will actually do, you will ask yourself how many fifths are actually contained in 1. You find out that we don't have any, and then here you add a 0. And how many fifths are contained in 10? You find out there is nothing. And then after that, you ask yourself, we add a 0 there, how many are there? And then you have a 2. Or simply put, in a calculator there, you can just say 2, and then you press a shift, you press a percent, you will see that you have 1 over 50. And if you notice this is the same as 0.02 as we did there. The second thing that we want to also do, what is 10%? And 10% we know that is going to be 10 times, and 1% is 1 over 100, so you have 1 over 100 there. And 10 is the same as 10 over a 1, which is the same as 10 times 1 is 10, divided by 1 times 100 is 100. And then what does this mean? It means that a 10% a piece is the same as I have 10 equal things out of 100 equal pieces or equal things. And also this is the same as, because we have a common factor between 10 and 100, and 10, how many 10s are contained in 10? We have 1. And how many 10s are contained in 100? We know that we are actually having 10. Or simply put, how many 10s are contained in 1? You will find out that we don't have any, and then you add a 0. How many 10s are contained in 10? You have 1. So this is another way of converting a 10%, and this 10% is actually the same as 1 over 10, or simply put as 0.1. So if you look into this, you will find out that if I am giving you a long answer question, I expect you to show this part, I expect you to show that part, and then you can go all the way until you are there. Remember that the question was saying only to fractions, so you're supposed to end somewhere there, not this part. But if I am actually giving you a multiple choice question, it's very easy, because all you need to do, you need to press it in your calculator and say 10%, this is a percent here. So this is one way to convert these percentages. Now, what I want us to actually do, I want you to actually take this part as a classwork, which is number C, D, and C, D, E up to F. Can you try and convert these percentages to fractions, or rewrite these as fractions? Only these four, and then you can send on our group and see if you are actually getting this the correct way. Remember that I'm looking for all these steps, including this one here. If let's say the question is saying convert to a decimal, I need all these 4 steps for 4 marks, and then you can send it on WhatsApp. Then we'll be able to proceed if you can actually do that. I will be waiting. If you have a question, you can unmute yourself and ask the question. Otherwise, let's do these problems. I'm gonna give you 3 minutes. I'll give you 3 minutes, and then we can move. just want us to convert what is 25%, what is 50%, and what is 75% is as a fraction, and also what is 100%. You can just send the solutions on our group. I will be able to see which one is actually what I'm looking for and which one is not what I am looking for. These percentages play a very huge role, because if, let's say, you don't understand these percentages, it's going to be hard for you to interpret. It's going to be hard for you to interpret the it's going to be hard for you to interpret discounts. It's going to be hard for you to interpret tax. It's going to even be more hard for you to actually deal with financial mathematics that we'll actually be dealing with around the last 3 to 4 chapters of this course. But if you can master this, then I don't think you will have a problem at all. You'll be able to move forward. What are the answers, guys? We're waiting. Okay, let's look at this one here. So 25%, you are saying it is the same as that, which is that, which is that, and which is that. And also 50%, you said that is 50, you have times 1 over 100. I think this one is 100% correct from Avele. This one is 100% correct. I think we can move now because someone have sent the solution. And also Tabisa, let me look into it. 25 is this, and we have that is correct. This one is correct, and all of them are correct. So I think we are good to go. Thank you, guys. Let's now move to what is important here. So I'm just gonna write these as they are. Of course, if you are having 25, this is the same as just we have Tabisa and also have Avel. I think they have done. And then when it comes to this, we said that we'll just have a 25 times 1 over 100, and then you divide that by 1. 25 times that is going to be 25 times 1 is going to be 25. 1 times 100 is going to be 100. How many 25s are contained in 25? You have 1. How many 25s are contained in 100? You have 4. And then, of course, you will end up asking yourself, how many 4s are contained in 1? You find out there is 0 there. How many 4s are contained in 10? You find out 4, 8, you have 2, and the remainder is 2. And how many 4s are contained in 20? You have a 5. And then, of course, here you do the same thing. You have a 50 divided by 1. And then you're gonna end up having 1 over 100. And then you have a 50 over 100, which is the same as 1 over 150, and then we have 2 of them there. And then, of course, here you will end up having 0.5 because there are 2 out of 10 and there are 0 2s out of a 1. So you have that. And then in 75, Lulu to Jevu have sent a solution. Let me double check this. Is that 5 over 20? What happened here? How many 5s are contained there? Okay, this, I think, Luto, what you did is also fine. it can be done. Number one, I think it's fine. Everything is fine here. Yeah, because you can have how many 5s in 25? You have 5, and then out of 100 you have 20 5s. I think, yeah, it's fair. This is also fine. And now let's look at 75% is the same as 75 divided by 1 times 1 over 100. And then this is going to be 75 divided by 100. And then you ask yourself, how many 25s are contained in 75? 25, 50, 75, so you have 3. And how many 25s are contained in 100? You are actually having 4 of them. And you can start asking yourself how many 4s and how many things that are actually there. Or simply think of this 100, remember 75 is the same as 75.0, and then dividing by a decimal, I mean the power of 10 is the same as moving the comma to the left. So who wants to join? Okay, is actually moving a comma to the left. So having 2 zeros, it means I'm moving it 2 times. So this is the same as 0.75. That's how easy this thing is. And then when it comes to this one, you can see that you are having 100 over 1 times 1 over 100, which is the same as 100 divided by 100, which is just equal to a 1. So that is what is important by number F, because I want you to note something here, that 1%, we said 1%, it is equal to 1 over 100. And also I want you to also note that 1 is equal to 100%. That is what is happening here, because this value here is 1 and this one here is actually 100%. So 100% is the same as 1 and 1% is the same as 1 over 100. So this is something that you always have to keep it to your mind, so that you can be able to convert from a percentage to a fraction, and also you can be able to convert fraction to percentages. Let's take some examples also. So we have a nice example here. The example is saying convert the following fractions to percentages. In other words, if I give you this fraction, can you actually tell us how can this be written in a percentage form? So let me give you 2 examples and then see if you can do 2 by yourself. So we have an A there. A is going to be, I'm going to say is 1 over 2. And then I'm going to have my B. My B is going to be 3 over 5. And then I have a C. A C going to be black. So C is going to be 5 over 8. And then I have a D. My D is going to be a 3 over, a 2 over 3. I wanted this to be a 2 over 3. And then I also have my E there, which is going to be 3 over a 10. Of course, these 3, I want you to do them as a classwork. And then if you can answer these questions, then we can go to more realistic examples, and then we can call it a day. I think 1 or 2 examples will actually be fine. I want you to convert this or write this as a percentage. But before we can do that, let's first try and convert these ones. Right. If you notice here, there is something that I want you to realize. I want you to realize that 1 over 2 is the same as 1 over 2 times 1. Can you note that? Because 1 times 1 is just 1, and then 1 is the same as 1 over 1. So 2 times 1 is going to be 2. So this is equal to that. And it's not a hidden secret that if I have this is the same as 1 over 2 times what is 1. We recently said that 1 is the same as 100%. So this one that is here, it is the same as 100%. And of course, if you are having that, you can see that 100% is the same as 100% divided by a 1, or simply put, 1 times 100 is going to be 100%, and then you divide that by a 2. And of course, if you look carefully into this, you can ask yourself how many 2's contained in 1? Nothing. But if you're asking yourself how many 2's are contained in 10, you will find 5, and there is no remainder. And how many 2's contained in 0? We are actually having a 0, and there is no remainder. Hence, half is the same as a 50%. So this is why when you actually do this, you end up getting some nice marks because you know what you are doing. But if you are using a calculator, all you just need to do, you just have to say 1 over 2, or if this is a multiple choice question and you multiply by 100, you don't multiply by 100% because this percent I want it to be there at the end. So you just multiply that and you get a 50, which means this is a 50%. And if you're having a 50%, you can double check by a calculator and say that you're having a half, which is that. It's not a big deal. This is way too easy for us. We have to keep trying until we can get it right. And if you look into this one here, I want you to realize that 3 over 5, or 3 out of 5 things, is the same as 3 over 5 times a 1. And you know that 1 is the same as 100%. And of course, 100% is the same as 100 divided by 1. And 3 times 100 is the same as 300% divided by a 5. And you can start asking yourself, how many 5 are contained in 30? You'll find out there are 6. And how many 5 are actually contained in 0? There are 0, and there is no remainder. So this is actually a 60%. Now, what I want you to realize is that if I have a total of 5 things, and then 3 of these things out of 5 of these things is the same as 60% a piece. So if you can have that, then I think you are actually good to go. Let's try and see if you can get this classwork right, so that we can move to some of the realistic examples that we are actually having, so that you will be able to interpret information that revolves around percentages. Can you give me the solutions to these 3 problems so that we can move forward? You can drop them in our WhatsApp group. I will be looking for all of them. Just drop the solutions there and see if we are getting the same thing, or I am too drunk, I am saying things, or I'm thinking of things that are not correct, so that we can discuss. Let's see if you can get these solutions. I'm going to give you 3 minutes. Think. Okay, let's say 4. At 14:10, you should be done because it's only 3 things and they are too basic. Too basic. I will be waiting. I'm waiting, guys, and I'm waiting if we can get the solutions right here. these are the problems. We are having these problems here. We wanted to convert them to percentages. Of course, we already have an answer by Tatongosi. So we are saying 5 over 8 is the same as that. Multiply by 100, you have 500, you have 125 over 2. And then from there, you asked how many? Oh, you have 4. Used 4 as a common factor. 125 over 2, which is 62.5. So this one is 100% correct. Let's look at number D. You did 2 over 3 times 1, and then you have this times 100, and then this is 200 over 3. How many out of 26? 6.67%. This one is 100% correct. Just to mention something here which is much more important. Whenever the number of decimal places is not mentioned, always use 2 decimal places. I think 2 decimal places is fine. Because when it comes to this, you will find out that this one is going to be 66.66666666. So there will be so many 6 that are there. And then when you are actually rounding off, 6 is bigger than 4. So you end up adding a 1 on one of the 6. That's why you have a 7 there. And then when it comes to this one, multiply by 1, this is going to be a 300 over 10. How many of these? We have 3 here, we have 0. This is correct. So, Tato, this is 100% correct. Is there anyone who have done something that is okay? I think this one is, we are almost done with it. Anyone who's not getting this thing, can you avail yourself so that we can help you before you lose some of the easy marks that are there? Asanda Mbambo, let's look. You have the same thing as, look into this 5 times 1, this is 8. And of that, you have 8 times 100. Percent 500, this fine, this is 30, and then E 66.7. This one is also fine because this is what we're looking for. 3 over 10, that's 30%, of course, and then 2 over 3, as hard as it might look, we have 66.6%. Then this one. So this one is fine. Asanda Mbambo. Who else? No one is there. So I think we are good to move. Let's just move to something else. No, this is fine. I think this is fine. There is no one else. Since there is no one else, let me do this. Okay, let us look at something else. This is also another example. I think this one is actually way more realistic. Let me first rewrite this just to confirm. So this one we just said is going to be equal to 5 over 8 times 1, which is the same as 5 over 8 times 100%, which is the same as over 1, which is the same as 500 divided by 8, which is the same as, but of course we have a percent there. And then this is supposed to be the same as how many. This, you divide this by 4, you will have a 2. Here, of course, we'll have 1, 2, 5. And then how many 2's in 12? You have 6, and there is no remainder. How many 2's that are in 5? You'll find out there are 2, and there is a remainder, which is 1. And how many 2's out of 10? We have a 5. So this is supposed to be a 62.5%. And then, of course, this next one, we do the same thing. 2 over 3 times 1, which is the same as 2 over 3 times 100% over 1, which is the same as 200% over 3. And then from there, you ask yourself, how many 3s in 20? You find out you have 3, 6, 9, 12, 18, 15, 18. So you have 6 of them. And then the remainder is a 2. And then you ask yourself, how many 3s are contained in 20? And then you have 6, and the remainder is 2. And how many are contained in 20 again? You have a 6. So this is supposed to continue to be 6, 6, 6, 6, 6, and forever. But now when we are rounding off, you see that this 6 is bigger than a 4, so we add a 1 here. So you end up having 67%. And then when it comes to this one, of course, this one is going to be 3 over 10 times 1, which is the same as 3 over 10 times 100%. And this one is going to be the same as 300% divided by a 10. And you know that out of 30, we have 3 tens, so you'll have 3, and there is no remainder. Out of 0, we have 0 tens, and there is no remainder there. That is why this is a 30%, or simply put, cut this 0 and that 1 0, so you are left with a 30 there. That's how simple this thing is. Now, if let's say you look into this, I want us to take a realistic example, because these are some of the things that you will end up having to do. You will end up having to analyze certain data if let's say you are doing research, or you want to analyze someone's work. And sometimes you have to also analyze, if let's say you are in an organization, you will want to analyze how much in percentage form is the money that has been used in expenditure or expenses, how much is the profit we made, how much is the capital, or relative to the capital, how much profit have we made. So we want that percentage, and also how much loss have we made if we're making a loss, and also how much money is used to fix the expenses, and also how much is used to variable expenses. So you might end up wanting to analyze those kind of problems. So only converting things is not always these are just the basics that we're doing. Now I want us to get a little bit deeper to these percentages, and also how these things are actually used in real life. Let's take an example here and see if we can actually understand what I mean by all these things that I am saying. This example is saying, given the pie chart below of 106 students. So we have a pie chart of 106 students who wrote business calculations test, who wrote business calculations test 2. Test 2. Right? So a pie means that you are having a whole thing. Suppose this is a nice pie. This is not actually looking nice, because if I'm saying this is a pie and it's not looking nice, you might not want to eat it. I think this one is a little bit better. Let me try again. Now you can eat it. So we have this pie, and this pie now is divided into 1, 2, 3, 4, 5, 6 into 6 equal pieces. So not equal, just pieces. And then this portion here, it is 2.83%. And then this portion here, I'm just gonna give this portion, it is 8.49%. And then this portion that is in this side, it is 22.64%. And then this one here, it is 29.25%. And then this portion here is also divided into 2. This one is 19.81%. And then this one here is going to be 16 point, let's say we are having because I want these things to actually end up adding to 100%. Let me say I have 100 here, minus 22.64 minus 8.49 minus 2.83 minus 19.81 minus 29.25. What is the answer here? So this one we have 16.98%. So these students, they got below 50%. These ones here, they got between 50% to 59%. And then this portion here are the students who got 60% to 69%. This portion here are the students who got between 70% to 79%. Of course, all of these have between. And then this one here, they got between 80% to 89%. And then these students here actually got between 90% to 100%. So you are given this information here. You're given a pie chart. This pie chart is saying this. If, let's say, I have these students which are 106 and I divide them into equal pieces, I can say that students who got between 60 up to 69% are a 22.64%, and also these are also some of the students who got a certain marks in the test. Now, excuse me, the questions are, let me write the questions here. The first question is saying, how many students are passed the test? That's the first question. And then the second question here is, how many students got between let's say 60% to 89%. And then the following questions, I want you to take them as a classwork, and I want to see what are you actually getting. So this C here is saying, okay, let me write this one. How many students got let me do this, failed the test? And then we have a D here. D is saying, how many students got between, let me just say here, 50% to 80, not 80, 179, 79%. And then the last one is saying how many students got between 90% to 100%. So we are having this number of students, and I will be waiting for your solutions for this on our group. But for now, what I want us to do, I want us to analyze what is happening here. We are having a total of 106 students, and also from there we know that these are the percentages that are given that are analyzing the performance of these students in the test. Now we want to find here the actual number of students who passed the test. So this is actually our first solution. So our solution is going to be here. Let me write the solution. We want to find how many, or the total of students who passed the test. So the first thing that I want us to realize here is this: students who got below 50% did not pass the test, but students who got between 90 and 100%, they passed the test, and students who got between 80 and 89, they passed the test, and students who got between 70 and 79, they passed the test, and students who got between 60 to 69, they also passed the test. So these are all the other portions that have passed the test. So it is this portion and that portion and that portion and that portion and that portion. So the first thing that you need to do, what is the total percentage of students who passed the test? So the total is going to be this percentage plus that percentage plus that percentage plus that percentage, because all these percentages are the percentages of students who got above 50%. So add this percentage and see the total. So we know that we have a total of, so let's add these percentages here. So we'll have a total of, so you will end up having a total of, we have 22.64% plus, where do we start? These ones, they all got above 50%. So we can just add these percentages. So 64, and then we have 29.25%, and then we also have 19.81%, and then we also have 16.98%, and then from there you can also see that we are having this percentage here, which is 8.49%. So you add these percentages here. Once you add these percentages, the answer you will get, I'm just gonna try and be faster as I can here. Time is almost up. So 22.64 plus 29.25 plus 19.81 plus I have 16.98 plus I have 8.49. And if you notice here, you'll find out that all these students in all these portions, this one, that one, that one, they got above 50%. That is why I'm adding all these percentages. So the total is supposed to be 79.17%. This one here is a total percent. Let me just see. Total percent of students. Right. But the question here is saying how many students passed the test. This is the percentage of students who passed the test out of 606. Now, How do we get this percentage here from this number? Because this one is a fraction of this percentage there. So what you need to do here, the number of students is going to be found simple as, I take this percentage as it is because this percentage is a percentage and it is counted out of 100. So if the total number of students were 100, the number of students who are supposed to pass the test is supposed to be this 97.17 if the students were 100. But we are having a total of 106 students who actually wrote the test, not 100. So basically what I need to do first, because I already have this nice percentage here, I want to first look into this number here and look into the percentage of that number. The easiest way to do this is simple as this. Convert this to a fraction, and then you take that fraction and you multiply by this number. Again, I'm gonna say this slowly. Take this number and convert it to a fraction, and then the fraction that you get, you multiply by this number over there. So what you need to do here is to just say 97.17 divided by 100 times 106. Not 106. The answer you're supposed to get is supposed to be, I'm just gonna say, divide this by 100%, multiply this by 106. Okay. So you are actually having a total of 103 students. 103 students who passed the test. So these are the steps that I want you to follow if you are answering these problems, if it's a long answer question. But if it's a short answer question, this is very simple, guys. Let's not make this thing hard. It's not hard at all, because if you look at this percent here, and this is 100% and this is out of 100. So if I want to change it and out of 60, 106, I just have to multiply that. Now, if let's say you were just having a multiple choice question, all you needed to do here is to just say 97.17, and then you you add this percent. This is a percentage sign which you get by shifting and press this symbol here. And then after that, you can just put this inside the brackets and multiply 106. 106. This is the simplest at its best, because this is the portion of the students who wrote the test. This one is the portion of students who wrote the test. So out of the student who wrote the test, which is 106, this portion here is the one that passed. That is why I'm saying that you can actually get this. And this, by having this percentage, it means that out of 100. But now I want to convert it out of 60. We divide by that. And then this is going to be our nice answer here. Out of, you multiply, the percentage is there with a calculator. But if you wanted to follow the long answer question, this is how you do it. Now, number B, how many students got between 60 and 89? So, which portion is actually between 60 and 89? If you look into this part here, you'll find out that we are having this portion is 60 to 69. This one here is 70 to 79, so it is still between that interval. And then 80 to 89 is this portion here. But this one is 90. We don't want 90, so it's not part of this. This one is below 50, it's not part of this. We're not looking for that. And then when you're looking for 50, it is not part of 60. So we are only looking for these three. 1, 2, 3. So we're having those three here in 60 to 69. So we add these. So what we are looking for here, the number of students is going to be simply as number of students is going to be equal to, we have a total divided by 100% times 106, because this is a total number of students we are having who wrote the test. Now I wanted to find the percentage out of 100. So all I need to do, I need to add these three things. So here I will have 22.64%. This is not good looking. Let me use a smaller font here. So we have 22.64% plus, and then I also have 29.25%, and then I also have a 19.81. I also have a 19.81%. So in a calculator here, let me do this. In a calculator here, I will end up having 22.64 plus 29.25 plus I have 19.81, and then of course the answer that I am looking for here is going to be 71.7%. So this is 71.7% all over 100%, which is the total percentage that we're supposed to have, and then multiply by 106. The answer that we are getting here is simply put as, I have 71 divided by 100 answer times 106, and then 106 answer, change it. So I have a total of 76 students. So this is actually the total of students. Or simply put, you can just take this 71%, 71.7%, and then you multiply this by 106. The answer you're supposed to get is simply going to be this 76. It is the number of students who got between 60 and 89. That's how easy this thing is. Don't make it harder than it is. Can you try and solve C, D, and E for me and see what you are getting, and send your answer to our WhatsApp group? I will be waiting. I will give you 4 minutes and see if we are actually having the same thing. If you have a question, you can ask. In the absence of questions, let's try and see if you can solve these problems, all these 3 problems. Let me make them closer to each other. And I also want to copy this pie chart here so that it is closer to where you are answering your questions. So this is the pie chart that we have, and I'm gonna make it a little bit smaller so that it is here. And also I'm going to put this a little bit up so that, and also this one a little bit, this one a little bit up, so that everything can actually appear. So this is the question. Can you try and solve this and give me the answers? I want to see the answers, guys, so that we can move to something much more important and see if we're moving in the same direction. Asanda, let's look at what you did. How many students failed the test? So if you are looking at the number of students who failed the test, we are having these students, they got below 50%, which means they have failed the test. So you took, let me put it here. So you took that percentage, which is 2.83, you divide by that, and then you multiply by 106. You are getting a 3, which is what we were looking for. So this one is correct. Let's look at number D. How many students got between, let me go back here. The first question, how many students failed the test? So we took that 2.8 and then divided by 100 and multiply by that, you got the answer. Thank you. And then the second question is how many students got between 50 to 79, which means that we are looking at 8.49 plus, because we're 50 to 79, and then 29.25, which is fine. And then the next one is 22, which is 62, 69, so we have 22.68. This one is fine, divided by 100 times. So this one is 3. Okay, when it comes to this one, what you did is fine, because we cannot have students which are comma 5. We can have 5, 6, or 7. We cannot have 5 or 2 comma something students. So that is why this is a 3. When it comes to this one, your answer should have been rounded off to be 64. So here you're supposed to just have a 64, because we cannot have 64 comma something students. So we're supposed to have a 64. And when it comes to this one, E, how many students got between that? So that is just 16.9 divided by 100 times that. This is correct. So you are having an 18, you round it off. So Asanda Mambo, I think what you did is 100% correct. Just change your D, just round off your D so that you are there. Guys, what is important here, what I want you to note is simple. Whenever we are having A% of P things, you must know that this need to be divided by 100% to remove the percentage, and times by the total number of things that are available. And then using a calculator like this one, all you need to do, punch this as it is in a calculator. And of course, the percentage here, you just press your shift. In this calculator is going to be a shift, and then plus this bracket there. So you press this and then that, then you will see the percentage appearing. You press shift and that, you can see the percentage appears. You can shift and press that, the percentage appears there. And of course, if let's say we're having 1%, that's suppose 1 over 100. So this is what it's supposed to be. I'm waiting for the answers, guys. I'm gonna give you 2 more minutes and then see if you are actually getting this. Asanda got this correct. Let me look now who also got the same thing as us. Avele, what did you do? This divided by that, that's 100%. This one is fine. Where's the next one? 64 is fine. And then let me look at this one. This one is also fine. So I think we are fine. This is what I was looking for. Any questions so far? Anyone who have a question? Anyone who have a question? You can ask the question if you have a question. just unmute yourself and ask a question. So if we can have a test, let's say Friday, that includes logarithms, anti-logarithms, and all those things in betweens, laws of logarithms and all those things, plus percentages. Do you think you will be able to get 100%? I have a question, guys. Okay, in the absence of questions, let's look. Mbali. 100 is that 3 students, and then this one add 64. Okay, this is correct. It is correct, Mbali. There's nothing to change there. Okay, I think we will end there for today, and then we will just look for the day and date for us to have our test 3, so that at least, even though we're disturbed, we can have 3 tests in this semester, so that next semester you know that we are left with 5 tests. In the absence of questions, I think that will be the end of our class. Hello? Since there are still students who might not come and collect their scripts, I think it is